Hi there, it's John Pushkar. I'm here today with another episode to bring you important safety insights into the world of fuels and combustion systems. Today's episode is all about performing a gas piping system audit at your facility. There are some very obvious things to look for when evaluating the safety of gas piping systems, and then some things that are very obscure and not so obvious. I'm going to take you into both worlds. Over the last 40 years, I've developed and led fuels and combustion equipment safety programs for the largest manufacturers in the world. Today, I'm bringing you knowledge, insights, and best practices about fired equipment and natural gas safety. Over the next few minutes, you'll get the kind of practical, real-life explanations that I've become known for. So one of the things you want to do is you want to start where the gas piping comes into the facility. Now, if you haven't seen Module 12 yet about isolation valves, you need to watch that because that's an important part of this. And I'm not going to again cover looking at isolation valves. Instead, I want to cover some things like corrosion protection systems. Did you know that every utility is mandated by law to provide periodic corrosion inspections of the underground systems that serve your facility? This needs to be documented, and you have the right to ask about the condition of your gas piping that serves your facility. In my book, Fuels and Combustion System Safety, What You Don't Know Can Kill You, I talk about a situation where I happened to be at a large auto plant, and there were smells of gas reported in the parking lot. There was a 400-foot line that went under the parking lot. It terminated in a gas pressure reducing little blockhouse close to the main manufacturing plant. Folks could never understand why there was a gas smell in certain parts of the parking lot. It ended up that that line happened to be like Swiss cheese. They reported this, the utility came in during a 2-week summer shutdown, and they started to dig that line and check it physically. It ended up being something that extended the shutdown another entire week because they could not get gas onto the facility till the entire line was repaired. And again, this was all on the gas utility. You don't need this kind of surprise if you're some type of manufacturing facility, maybe a hospital, someone who has critical occupancies. So lesson number 1 is ask the utility for these records, be a partner with them in understanding the condition of those lines. Now here's another issue. Where those lines come above ground, the utility seeks to isolate themselves from your piping system. So there will typically be isolation washers, bushings, gaskets between flanges, because they don't want to be impacted by whatever you're doing with the piping. Oftentimes when gas piping from a utility extends above ground, goes to a metering station, it ducts back down underground and is distributed through a large site. This site of yours may not have cathodic protection on those gas piping systems. Or if so, you may have no idea what the condition of those cathodic protection systems is. You'll need to get a hold of a corrosion protection engineer or someone who provides these services to come evaluate what the condition is of your underground piping and your cathodic protection system. Again, you can get that from the utility, but you might be the biggest offender there. And you don't want to be surprised by that type of a thing. I've been to facilities where there's horrible smells of gas out in the middle of nowhere, walking along a wooded area, and you see a puddle on the ground and there's bubbles coming up through it that are actually natural gas leaking from an underground line. You don't want this condition because it's an extensive purge and repair, and you'll be down for a while. The other thing you'd want to do is you want to look at exterior corrosion protection. What's the condition of paints and coatings that are on some of the piping systems? What's the condition of fasteners? You want to get yourself a paint thickness gauge. They're relatively inexpensive. You lose thousands of coatings annually just due to oxidation in the atmosphere. Paint on piping systems are not necessarily there to make them pretty. They're there as part of an exterior corrosion protection system, which you must protect and maintain. Other things you want to look at. Are gas lines labeled? Maybe labeled according to the pressures that they're at. Are hangers in place? Are you walking the line looking to see that hangers are actually making contact, that they exist where they're supposed to? I've worked with many companies through the years to develop proprietary checklists, especially those in the power industry, so that they can do consistent, comprehensive audits of their gas piping systems. If you're not doing this, if it's not even part of your radar screen, you're in for a surprise, and it won't be a good surprise. I'm going to share with you some information from the Prescient Technical Services module regarding piping system failures and corrosion protection systems. It'll give you a little bit of an insight into some of the things I'm talking about. And at the end of the day, the life that you save, it just might be yours. So we're next going to cover corrosion. Corrosion is the broadest and most complex failure mode that's presented in this module. It's the largest section, and there's a lot to absorb here. So what is corrosion? Well, a good source for you to move on and have an in-depth understanding about corrosion past this module is the National Association of Corrosion Engineers. They define corrosion as the deterioration of a material, usually a metal, that results from a reaction with its environment, or the tendency of a refined metal to return to its natural state as an ore. And we'll look at both of these phenomenon. So steel, for example, doesn't want to be steel. Out in nature, it wants to return to iron ore. If you don't know much about the way steel's kind of made by two processes. One is in mini mills where we reheat scrap and add additives. The other is the primary method where we take iron ore pellets, make them into iron, and then refine that iron into steel by removing some of its carbon content. So ultimately, steel is iron. It wants to return to that most basic form, and it wants to blend back into the ground. A lot of corrosion occurs with what we call corrosion cells. This is a basic corrosion cell. I'm showing you an iron or steel pipe wall that's submerged in water or soil. This is showing a cathodic area and an anodic area. There are different charges on molecules here. They're being attracted away from the base metal. They're coming out of solution with the metal, and they're moving back to pure iron. Here's just 4 of the many ways that you could describe corrosion. There's general or uniform corrosion, pitting or localized corrosion, crevice corrosion, and corrosion under insulation. I'm going to provide what I believe are some interesting technical papers about how some of these have caused major problems in refinery explosions and other types of major industries. Uniform corrosion is the most common form of corrosion. Normally occurs on bare or uncoated pipe, and you can see here in the picture underneath mine that this pipe that's sitting mostly submerged for long periods of time has lost a somewhat uniform amount of wall thickness. Localized corrosion is where there's cavities, pitting, or holes produced on pipe or some metal wall. There's a rapid rate of pipe wall loss. In the corrosion industry, on piping systems, where there's an imperfection in the coating that's applied as corrosion protection, they call that imperfection or that missing area of coating a holiday. It's hard to predict the rate of localized corrosion and to control it or even to monitor it. Another popular type of corrosion is called crevice corrosion. You could see it here in a number of piping applications where pipe is supported touching pipe slides underneath pipe racks where we just have this small amount of contact area where there isn't a lot of air movement. One of the papers that I'm presenting to you identifies this as one of the leading causes for a horrible catastrophe. Last but not least, there's corrosion under insulation. You could see here in the picture there's been some insulation removed, and on this section of pipe you could see some substantial corrosion has occurred. This is difficult to identify. It would require you to be taking periodic samples in places where you knew there was the potential for this. Quite often, if piping systems have dead legs where there's condensate, for example, that's allowed to cool, or where there's water spray and piping doesn't have the ability to dry
and the insulation soaks it up and keeps the surface of the pipe wet, there could be great potential for corrosion under insulation to occur. Some areas where this is most likely are where there's intermittent operation, again where the insulation or jacketing has been damaged, and where the insulation's been wet or can absorb water. I'm showing you a system there on the left where the insulation's been removed, and you could see that there's been substantial corrosion for years. And like I said, it would require the periodic removal of samples or cores to identify it. So areas that are most susceptible to corrosion under insulation also include pipes operating continually at between 25 and 250 degrees, or they're operating above 250 degrees but intermittently. Piping systems that vibrate a lot because the insulation gets damaged, piping systems that have damaged wrappings, and near steam vents or humid areas, or where, for example, there's mist from cooling towers that occasionally blows their way, or there have been known piping leaks. Acid vapors can also be a contributor to corrosion under insulation. You could condense acid vapors through insulation onto the pipe and keep them locked there.
Hi, it's John Pushkar. I hope you found this episode useful. If you'd like to know about more ways that I can help, you can check out my website at www.prescientts.com. There you'll find information about the Prescient Technical Services Online School, my book, Fuels and Combustion System Safety, What You Don't Know Can Kill You, and also about some of the consulting projects that I've been providing to clients for the past 40 years. Things like implementing inspection and testing programs on a corporate enterprise-wide level, things like reviewing and commenting on capital equipment purchases that involve combustion equipment, and even being a legal expert if things go really wrong. Once again, thank you for attending, and remember, be safe out there. The life you save, it just might be yours. Folks, I hate to go here, but I need to provide you with a disclaimer. I never know how people are going to interpret the things that I say and present, so I've got to make it crystal clear here. Most of the things I talk about require very specialized knowledge to implement. The courses that I offer are awareness level courses. There's good information in there, but being able to actually implement these things requires both knowledge and skills. Knowledge is what we learn in books, what you'd learn watching me, listening to me. Skills are the hands-on part that we can't do together over a video. So please don't take a little bit of this and have enough information to be dangerous. I need to tell you that neither Prescient Technical Services or myself, John Pushkar, the presenter and author of this work, warrant or represent expressly or by implication the correctness or accuracy of the content of the information presented. The user or viewer of this work accepts any legal liability or responsibility whatsoever for the consequences of its use and its misuse. Thank you again for watching this episode, and I look forward to having you back.